Okay, so in the last video we were talking about increasing and decreasing functions, and now we're looking at what happens in between increasing and decreasing. Okay, so down on this particular one here we've got the function is decreasing and the gradient was negative, and on this side the function was increasing and the gradient was positive. So in between negative and positive is the number 0. Okay, so what we have here is if we did the tangent, we'd have a gradient of 0. Okay, so stationary point. Y dash equals 0. So it's when the function is neither increasing or decreasing, it's stationary, and the tangent would be parallel to the x-axis. Okay, so the tangent is parallel to the x-axis. Okay, so copy and come across when you're ready. Okay, so we can have more than one turning point, and so what we've got here is what we call a maximum turning point. Turning points. And so I just call it max TP. Max TP. And here it's turning at the bottom, so we call that a minimum TP. Okay, and there's another way we can also say it's it's concave down as well at a max, or it's concave up for a minimum turning point. Okay, again we've had these sort of expressions before, like sad faces and smiley faces, but when you have a roller coaster then you don't use those sort of expressions. Okay, copy that and come across when you're ready. Okay, so can a turning point exist on a straight line? The obvious answer is no, but let's see how the maths works out. So y dash equals 3. If it's going to be a turning point, y dash equals 0. 3 cannot equal 0, therefore 3x plus 7 does not have a turning point. And we knew that anyway because it's a straight line. Okay, that's a straight line. A straight line doesn't have a turning point, but the maths is y dash equals 3. 3 can't equal 0, so 3x plus 7. So y equals 3x plus 7 does not have a turning point. But let's look at some on the next pages where we do have turning points. Copy and come across. Okay, so I've got 3 up there. We might just do the first 2. So we got, obviously this one is an upside down parabola, so we know we're going to have a turning point, but the question says find them. Okay, now turning points, stationary points are the same things. Now this one here is a cubic, and it's a positive cubic, so it's this sort of shape roller coaster. Okay, so we're going to have 2 turning points for this one, but we'll find them mathematically. So first step, y dash equals 12 minus 4x. Now at a turning point, y dash equals 0. Therefore 12 minus 4x equals 0. 4x equals 12. X equals 3. Now we've got the x value, we need to find the y value. So at x equals 3, y equals 9 plus 12 times 3 minus 2 times 3 squared equals 9 plus 36. 3 squared is 9 minus 18, and that equals 27. Therefore 327 is the turning points. Okay. We know it's a max TP because we know our things, but we'll worry about how to find the nature of the turning points on the next video. Okay, so let's have the next one. So we've got a different letter, and we've got different letters. So we're going to have P dash equals 6t squared minus 10t minus 4. 10t, 6t minus 10t. Yep, that's okay. Take out the factor 2. Okay, now that's a quadratic, so we can still factorise it. So 3t t minus 2 plus 1 gives me minus 6t plus t, which is minus 5t, which is what I want. So I've got t, 3t plus 1, t minus 2 at turning points p dash equals 0. And so our values are not p equals, it's t equals. So t equals minus 1/3 and positive 2. Okay, so there's a bit of maths to do. So I need to see what the function was again. So at t equals minus 1/3, p equals 2 times minus 1/3 cubed minus 5 times 1/3, so minus 1/3 squared minus 4 times minus 1/3 plus 13. Alright, so I've got 1 over 27, so it's 2 over 27 for the first number. Negative, sorry, a negative 2 over 27 because that's a negative cubed. A negative squared is positive, but I've got a negative, so it's going to be minus 5 over 9 plus 4/3 plus 13. I'm going to get my calculator out. Okay, turn the calculator on. So you've got minus 2 over, clear, 2 over 27. Just amuse yourself while I'm doing this. So I've got 13 and 19 over 27. So the first turning point is that number. And now still going to do the second one. At x equals 2, this will be a lot easier. P equals 2 times 2 cubed minus 5 times 2 squared minus 4 times 2 plus 13. This will be easier. 8 to 16 minus 20 minus 8 plus 13. Minus 28 minus 28 plus 29 equals 1. So the second turning point is 2, 1. Okay. We won't worry about the third one. Let's see what on my next slide. And that's it for the time being. So I'm just back. I've just added another slide. So just make sure you copied all that down. Okay. And then when you're ready, come across. Okay. So I'm just going to add another one. Sometimes you're not given all the information about the curve, but you're given clues again. So these are the interesting questions. Okay. So what we know is we've got to find A, B, and C. Okay, so we get clues. So the first thing we do is when x equals 0, because that's a nice easy one, y equals 0 plus 0 plus 0 plus c, but we know that it equals 5. So that means the first value is 5 equals c. Okay? So when x equals 0, y equals 5, and then 0 just cancels out on all those terms. So we know that c equals 5. We know that there's a stationary point at x equals 2. So we've got y dash equals 3x squared plus 2ax plus b. And we know that it equals 0. So 0 equals 3 times 2 squared plus 4a plus b. So 0 equals 12 plus 4a plus b. And so just rearranging that, 4a plus b equals minus 12. And you should recognise this as part of a simultaneous equation. But when you've got two letters, you need to have two equations, and the second equation is going to come from the fact that we've got a value 7. So when x equals 2, y equals 7. So we can say that 7, going back to the original equation, we've got x cubed plus a times x squared plus b times x plus c, but we know that c equals 5. Okay, so let's put that in. And we just got to tidy up. So 7 equals 8 plus 4a plus 2b plus 5. Keep tidying it up. So 4a plus 2b. Take those numbers across. So 8 and 5 is 13, so it equals minus 6. And that's your second equation. So there's your first equation, there's your second equation. So let's line them up underneath each other. So I've got 4a plus b equals minus 12. Okay, and we'll subtract to get rid of the a's. So 2b minus b is 1b, minus 6 minus minus 12 equals a plus 12 equals 6. And then that's our second letter. And then to find a, we've got 4a plus, we just use that first equation, 4a plus 2b equals minus 6. 4a plus 12 equals minus 6. 4a equals minus 18. A equals minus 4.5. So unless I've made a mistake somewhere in my maths, a is a fraction. So we've got a equals minus 4.5, b equals 6, and c equals 5. Okay, and the exercise that we'll be doing eventually, we're going to do the, I'll do one more video on stationary points, but it'll be on exercise 20C. But I want you to watch the next video, which is the nature of turning points, determining what's the max and what's the min before we go on to the exercise. Okay, that's it.